Welcome to The Explainer. Today, we're going to talk about something kinda strange and honestly pretty dangerous that can happen inside our own bodies. We're going to look at what happens when your body's survival instincts actually turn against you, all because of a failing heart. So let's just dive right in. We're going to unpack this wild paradox where the body's own emergency response system, a system designed to save your life, ends up making the problem it's trying to solve even worse. Now, to really wrap our heads around that paradox, we have to start with the basics. What is the fundamental issue at the center of all of this? To put it as simply as possible, heart failure means the pump is failing. The heart muscle just can't do its one single crucial job, moving that oxygen-rich blood to all the parts of your body that are desperate for it. And this one problem, this drop in what's called cardiac output, it's like a massive alarm bell going off inside the body. It absolutely does not go unnoticed. In fact, it triggers a system-wide, all-hands-on-deck emergency response. Now, what's really interesting is that a heart doesn't just fail in one way. The pump can actually break down for two very different reasons. Okay, so on one side, you've got what we can call the squeeze problem. The heart muscle itself is just too weak to contract hard enough to push the blood out. But on the other side, you've got the fill problem. In this case, the muscle is too stiff, so it can't relax and let enough blood in between beats. But here's the kicker. Whether it can't squeeze or it can't fill, the end result is exactly the same. Less blood gets where it needs to go. So, cardiac output drops. Does the body just sit there and take it? No way. It immediately launches this super fast first line of defense. Think of it like an internal SWAT team getting deployed. And this whole thing happens lightning fast. You've got these tiny little sensors called baroreceptors, basically acting like security guards in your major arteries. The second they feel that pressure drop, they smash the alarm button. That signal zips straight to headquarters, the brainstem, which immediately activates the body's fight or flight response. So what's the game plan for this fight or flight response? Well, it's pretty simple and direct. Make the heart beat faster and squeeze harder to try and force more blood out. And at the same time, it tightens up all the blood vessels to drive that blood pressure back up. It's basically a short-term brute force solution. But that super fast nerve response, that isn't the only system that gets the emergency call. A slower, but you could argue way more powerful system also gets involved, the hormonal system. You see, your kidneys are incredibly tuned into how much blood they're getting. When they sense that they're not getting enough, they release this chemical trigger called renin, and this one little enzyme kicks off a really powerful hormonal chain reaction. And this is the body's long game. That renin leads to the production of this incredibly potent hormone called angiotensin II, which has a mission to fix that low pressure problem everywhere in the body. Okay, so let's just pause here, because this is the crucial point. The body is now fighting this battle on two fronts. You've got the nervous system making the heart work harder and squeezing the pipes, and now you have this hormonal system squeezing the pipes even tighter while also pumping more fluid into the system by making the kidneys hold on to salt and water. And right here, this is where we get to the heart of that paradox we talked about at the start. This is the exact moment where the body's heroic, life-saving efforts start to backfire. Big time. Let's really break this down. All that extra fluid from the kidneys increases what's called preload. Just think of it as the amount of blood stretching the heart before it even tries to pump. At the same time, all those tightened blood vessels increase afterload. That's the resistance the heart has to push against. So what the body has done is it has overfilled the system and narrowed all the pipes for a heart that was already struggling. You'd think so, wouldn't you? Blood pressure is up. It looks like a success on paper. But underneath that short-term fix, there's a really devastating long-term consequence brewing. And hey, let's give the body some credit. For a little while, this actually works. The brain, the kidneys, all the vital organs, they're getting the blood flow they need to stay online. From a pure survival point of view, it's a win. But here's the loss. All of that extra volume and all that extra pressure puts a massive strain on the already damaged heart muscle. This constant stress actually causes the heart to get weaker and change shape for the worse. It's a process the source material calls maladaptive remodeling. And that's the trap. The heart fails a little, so the body's compensation systems kick in, making the heart work even harder. But that extra work causes the heart to fail even more, which then triggers those systems even more strongly, and it just goes around and around in this terrible downward spiral. And this question right here, this is the key to all modern heart failure treatment. The whole goal isn't just to support the heart, but to actually interrupt the very systems that are trying to help. It's a case of trying to save the body from its own best intentions. And it really makes you wonder, how do you do that? How do you break that cycle?